Hello there, today we're doing binary tree, right side view. Let's check it out. In this particular problem, we are given a binary tree. So each node has a left and right node. And what we're going to do here is try to get the rightmost node. In this case, it's the 1, and the 3, and the 4. So how does that work? Well, we just basically do a breadth search, and we take the last node and we insert it. So let's run through that. Here's a queue, here's the results. The queue has a root. Let's take that root, and once we hit the barrier, we throw that into results. So the 1 goes into the barrier, and we throw in the 2 and the 3, and we have that in the results. Now, next item. So 2. So how do we keep that? We keep that as called the rightmost item, and we set that as going to be every single node until the last node, which we store. So now we have a 2. It's going to be rightmost is going to be 2. We have a 5, and then we look at the 3, and we changed rightmost to 3, and we insert the 4. And that means we insert the rightmost, which is 3, into our results. Then we have 5 and a 4. So what happens then is that we check out the 5. That becomes the rightmost. There's no new nodes. Of course, there is none and none at this point. And we drop in a 4. And that's going to be our new rightmost. And of course, we have none and none. And our array, queue can go through that if we desire. If we do not desire to have nones in our queue, we can just eliminate those by setting to make sure that we don't add them to our queue if it doesn't exist. Okay, anyways, with that, our rightmost is 4 once we hit the end, and we return results 1, 3, 4. Okay, let's code this out and do something cool. So q equals dq, q.append the root. What happens next is we set the results, and while q, what we're going to do is create the rightmost, and for I in range of length of q, what's going to happen is we're going to set the if the node equals the q. I don't know why I did that. Q dot pop left, and if node rightmost is equal to node. Also, q dot append node dot left, and q dot append node dot right. We'll take care of the rest later. So with that, yeah, we're good. So if rightmost the end, then result dot append the node. Why this is okay is because we set rightmost to none every single time. And even if we put nones in our queue, that's fine because this does not run, and so we don't need to change. We don't change rightmost, and so we don't append anything to results if there's nothing. If it's a none, so return results. But it's going to be a little bit slower because we're going to be adding a lot of unnecessary items into into our we'll need to append right, no dot value. We don't need to append those items. So let's submit. Okay. Oh, none. Okay, that's not supposed to. Rightmost. Submit. Alright, looks good. So the timing is a little bit slower. Now suppose we did a if node left. So we did node left is equal to node dot left, and node right is equal to node dot right. Oh, better yet, node dot left, and just append it. And if node dot right, append node dot right, and that way we'll eliminate the nuns that we insert, and that speeds up our code a little bit. Well, with that, I hope you enjoyed our video. If you like the video, like and subscribe. If you want more videos, check the link in the description below. If you have questions, please comment. And yeah, I'll see you next time. Bye.